Welcome everyone. For today's episode, we are going to perform an enjoyable yet informative experiment featuring the natural pH indicators. But before we start, may I introduce myself? My name is Hanyewi A. Tambuli of Section 1, taking up BS Medical Technology in FEU Manila. Now to start off our experiment, let us first define what is acid and what is base. Now, according to our sources, there are three common definitions of acid. We have the Arrhenius acid, which is said that acid are any substance that increases the concentration of hydrogen ions in solution. Brown-Stadelary acid, defining acid as any substance that can act as a proton donor. And lastly, Lewis acid, expressing that acid is any substance that can accept electrons. Bases, on the other hand, are defined as any compound that donates an hydroxide ion in solution. Bases are any compound capable of accepting proton. Lastly, bases are any compound capable of donating an electron pair. Now that we have the idea of what is acid and what is base, let us now know what is the differences. The difference of acid to base. Acid have the characteristic of being sour, changes the color of litmus from blue to red, and it reacts to bases to form salt and water. We can actually find some example of this acid. We have vinegar, we have sulfuric acid, and then we have tartaric acid that can be found in baking soda. Often you can find them at home. Now on the other hand, bases often taste bitter. They turn red into litmus blue. They have a soapy texture, and they react to acid and form salts. Example of base are sodium hydroxide using for soap and detergent. We also have ammonia, frequently used in nitric acid, fertilizer, and cleaning agent. So today's experiment focuses on natural pH indicators. But do we have idea what is pH and what is pH level? pH is simply the scale used for measuring the acidity in the basic of a solution. It is calculated by taking the negative log of a concentration of a hydrogen ions in aqueous solution. pH level ranges from 1 to 14. Solutions with lower concentration of hydrogen ions have the higher pH level and considered basic, while pH level 7 is considered a neutral. However, solutions with higher concentrations of hydrogen ions have the lower pH level and considered acidic. Today's advancement of technology is already spectacular. Various instruments are already created to test the pH levels of many substances. However, today we are going to create our natural pH indicators using natural resources like plants, which have their natural pH indicators. In this experiment, we are hoping to test the accuracy of these natural resources in detecting the pH level of some household materials, and also to gather information that could further help us in learning more.
Hello everyone! I am Rasa Joy C. Galindo from Section 1, and I am currently taking Bachelor of Science in Medical Technologies at Far Eastern University. For today's video, we will be conducting an experiment entitled Eggplant as Natural pH Indicator. But before we start, let me remind you some of the safety precautions that we need to keep in mind in order to successfully conduct this kind of experiment. Since we are dealing with acids and bases, safety precaution is a very important thing to remember. First, make sure that your hair is tied to avoid distraction. Second, as you can notice, I am wearing laboratory gown. This is to protect my skin from unwanted birds. Third, I have here surgical mask. This is to protect my body, especially my respiratory system, from the smell of those harmful chemicals. Next, we have here disposable gloves. This is a very important thing to have when we are conducting this kind of experiment. Surgical gloves is suggested when available. And lastly, we have here tongs. This is to pick up those hot solutions that we will be dealing later. So, those are the safety precautions that we need to remember before we conduct this kind of experiment. So, what are we waiting for? Let's now start the experiment. For this experiment, it has two parts. First is the preparation of our natural pH indicator, and the second one is the testing of our samples. For the preparation of our natural pH indicator, we will be needing at least 2 peels of eggplants that was prepared ahead of time, so it was dried. Next is approximately 250 ml or 1 cup of water, heat-resistant container, plastic cups for our samples, syringe without needle. This is just optional. You can use dropper or any measuring cups that is available in your area. And as mentioned, tongs. So, let's start the first part of our experiment. So, the first step of this experiment is to make sure that our eggplant peels were dried. So, make sure it was prepared ahead of time. The second step is we will boil this approximately 1 cup of water. So, let's go! So, after boiling our water, we will pour it to our heat-resistant container. Careful because this is a hot water.
Parang kumakas na ito. Pero maraming kumplino eh.
And we will soak our dried eggplant peels.
Konti lang may tubig. Kulang. Bigyan mo lahat.
So, we will soak it for at least 3 to 5 minutes. So, after 5 minutes, we will now remove the eggplant peels to our solution using our tongs, of course. Our eggplant peels turns into yellowish green. Look. It's now yellowish in green and it's not violet anymore. You will also observe a change in color in the water that we use. So this will be our natural pH indicator. We will just cool it down for the next step of our experiment. So, for the second part of this experiment, we will now be testing our samples. And for the preparation of our samples, we will be needing, of course, tongs, plastic cups, syringe without needle, vinegar, lemon juice, water, measuring spoon or different sizes of spoons, and tape and pentel pen for labeling. So, let's start! So, for the first step, we will be labeling our plastic cups using our tape and pentel pen. So this is our lemon juice, L, J. Next is for our vinegar. We will label it as V. And lastly, for our water, we label it as water. So, after properly labeling our cups, we will pour the samples to its designated place. So, first we have vinegar. We need 2 tablespoons of vinegar. Careful. 1, 2. Next is our lemon juice. So for the lemon juice, we'll be needing 5 drops. Okay, just 5 drops of this sample. Using our syringe. So, for the lemon juice, we will be needing 5 drops of this sample. So, using our syringe, 1, 2, 3, 4, 5. So, there. 5 drops of lemon juice. And then next is water. Only 1 teaspoon of water. Now that our samples are prepared, let's start the experiment proper. Before we pour our natural pH indicator, let's make sure to add 1 teaspoon of water to each sample. So since this is water, we will not include this anymore. So just vinegar and lemon juice. One, 2. There. After that, let's get our natural pH indicator that we prepared a while ago. This one. And then, let's pour at least 2 teaspoons of this to each sample. So for the water, 1, 2. For the vinegar, 1, 2. For the lemon juice, 1, 2. To observe the change its color, we can add more indicator to each sample. So, let's wait for a few minutes for its change. As you can notice from our final product, the solutions change in color. This is because they have different pH levels. So let's see. So this is the color of lemon juice and this is the color of vinegar. They are almost the same. Why? Because both solutions are acidic. The pH level of lemon juice is 2, while the pH level of vinegar is 3. So the lower the pH level is, the more acidic the solution will be. So as you can see, it is yellow. So that will happen if we pour our indicator in the acidic solution. On the other hand, water turns to be darker or turns to be color brown. This is because water is neutral. It has a pH level of 7. That's why it is darker compared to those acidic solution. So, how about the bases? The bases samples will be further discussed by one of my group mates. So that concludes my part in this experiment. Let's see what will happen in the base part.
Hi, I am Mary Quincy, an FEU Medical Technology student, and today we will be doing a base experiment about pH indicators. But first, let me remind you to wear personal protective equipment since we will be dealing with some chemicals. Always remember that wearing personal protective equipment is the most important thing when we are doing an experiment to avoid harm and illness. After accomplishing that, let's now proceed to the experiment proper. First, prepare your chosen base sample and label them properly. Next is, add 1 teaspoon of water in each sample and mix them thoroughly. After that, add 1 or more teaspoons of natural indicators in each cup and wait for the reaction. After a few minutes, you will notice a change in both samples. The baking soda turned into a rusty brown, almost green color, and the laundry soap turned into a bit old green brown in color. And that concludes the base part of this experiment. Now, let us proceed to answering some guide questions. The natural pH indicator that we used turned into a lighter shade of yellow when it was poured into the acidic solution. From the previous experiment conducted by Miss Rachel, she used vinegar and lemon juice as a sample, which has a pH level of 2 and 3. From this, we can say that the lighter the indicator, the more acidic the solution is. Another sample used by Miss Rachel was pure water. This time, the natural pH indicator turns to be darker than the acid solution. This is because the pH level of water is 7. meaning it is neutral. It is expected to be darker than the previous solution with acid samples. The color of the indicator for the basic solution is green, and from that, it will soon turn into a dark color that will indicate the pH level of the base solution. From the experiment conducted by Miss Mary, she used baking soda and powder laundry soap as a base sample. The baking soda turned into a rusty brown, almost as urine color, and the laundry soap turned into a bit old green in color. The most acidic sample was the vinegar and the lemon juice. As mentioned, their pH level were 2 and 3. Therefore, the indicator appears to be lighter. Next will be the pure water. It is neutral. It is neither acidic nor basic. This characteristic gives the indicator a darker color compared to the previous sample. The less acidic was base solution, which are baking soda and laundry powder. Their pH level is 8.3 for baking soda and 10 for laundry soap, which is why the indicator appeared darker. The organic compound responsible for the color change was the anthocyanin content of our natural indicator. This organic compound has a formula of C15H11O. So, how it is responsible for the color change of our samples? Anthocyanins change in color depending on the pH level of the solution where it was soaked. There is a shift that was happening in their molecular structure whenever it was exposed to a more acidic or basic solution. For instance, when we mix anthocyanin solution into an acidic sample, its molecule will be protonated, meaning the phenolic OH group of anthocyanins contains hydrogen, which makes it cation. This makes the light yellow color of our acidic sample with anthocyanins. On the other hand, when the anthocyanins were exposed to basic samples, their molecule will be deprotonated. Hydrogen was removed from the phenol groups. Then, the basic sample with anthocyanins turns into a darker color. In short, the pH level of the sample will be the basis of the shift in the molecular structure of anthocyanins, and from there, it changes the color of the solution. If we go back to the procedure of our experiment, we notice that we soaked the dried eggplant peels in the hot water. After that, it became yellowish green. We can say that it is one of the highlights of the experiment because here we extract the anthocyanin content of the eggplant peel. As mentioned, it is the organic compound responsible for the color change in our solutions. We can also conclude here that anthocyanin gives the eggplant peel its purple pigment because after it was extracted, dried peels turn to be yellowish green. It does not retain their natural color. So, what's the relationship of this to the red cabbage? Red cabbage is rich in anthocyanin that also gives the purple pigment to the vegetable. Overall, red cabbage and eggplant can be used as natural indicators due to their anthocyanin content. We therefore conclude that the color change will determine the pH level of the sample through different kinds of indicators such as litmus paper or nature indicators, such as red cabbage or eggplant. We can see the difference of our acids and bases and natural samples. And this ends our experiment entitled Eggplant as Natural Indicator. Thank you very much for watching and goodbye.